MCEN 1131 Engineering Mechanics, Statics, Fundamentals of Trigonometry, prepared by Mirko Dumanovic. In mathematics, trigonometric functions are functions of an angle. They're used to relate the angles of a triangle to the length of its sides. Trigonometric functions are very important in the study of triangles and other subjects, including, but not limited to, statics, dynamics, design, and aerospace engineering. The most common trigonometric functions are sine, cosine, tangent, and cotangent. Definitions of these functions are listed on the next couple of slides. Use figure 1 on the left and follow along. Sine. The sine of an angle is the ratio of the length of the opposite side to the length of the hypotenuse. In our case, the sine of capital letter angle A is side lowercase a divided by side h. Cosine. The cosine of an angle is the ratio of the length of the adjacent side to the hypotenuse. In our case, the cosine of capital A is side B divided by side h. Tangent. The ratio of the length of the opposite side to the length of the adjacent side. In our case, the tangent of capital A is side lowercase a divided by side B. Cotangent. The ratio of the length of the adjacent side to the length of the opposite side. It is the reciprocal of the tangent. In our case, the cotangent of capital A is side B divided by side lowercase a. Unit circle. A unit circle is a useful tool in understanding sine and cosine angles found in right-angled triangles. It is so named because its radius is exactly 1 unit in length, usually denoted as just the number 1. The circle's center is at the origin, typically labeled 0, 0. Let us now turn our attention to the Pythagorean theorem, which itself states that in any right-angled triangle, the hypotenuse squared is equal to the sum of squares of the remaining two sides. In figure 2a on the bottom left, these sides are marked as h, a, and b respectively. If we apply the Pythagorean theorem to the right-angled triangle ABC in figure 2a, we will obtain figure 2b. Using the Pythagorean theorem in conjunction with a unit circle such that the hypotenuse is equal to the length of the radius, which itself is equal to 1, will produce several unique results. Please pause the video here and review each of the ones listed on this slide. Here are a few geometric principles that you should already know. Spend some time and ensure your familiarity with each of them. Use the figure below and follow along. Sine law. The sine of alpha divided by side A is equal to the sine of beta divided by side B is equal to the sine of gamma divided by side C. Use the figure below and follow along. Cosine law. C squared equals A squared plus B squared minus 2AB times the cosine of gamma. B squared is equal to A squared plus C squared minus 2AC times the cosine of beta. A squared is equal to B squared plus C squared minus 2BC times the cosine of alpha. End of lesson 3. In our next lesson, we will review and renew some concepts of vectors and scalars that you would have covered in high school.